Antiderivatives continued. Okay. Now, the first thing we're going to do is we're going to talk about what we talked about all along in our derivatives videos about a ball being dropped from the top of a building. Okay? Now, Galileo said that all objects near the Earth's surface have a downward acceleration of 32 feet per second squared. Ta-da! Okay. Now, we're going to take the first letter of the word acceleration, and we're going to start the equation this way. Acceleration is 32. Okay? Now, we're going to say we have a derived equation. We've derived acceleration from velocity. Okay? Now, velocity is a little different than speed. Speed always goes in an upward direction. But velocity can either go up or down. You can have a negative velocity, you can have a positive velocity, depending on whether your object is slowing down or speeding up. So we're going to use velocity from now on. So we have a derived velocity of 32 t to the 0. Now anytime you have t to the 0 or any other number, say you have the number 365 to the 0 power, then that number is just flat out 0. Okay? Anything you raise to a 0 power is automatically going to be 0. So, the derived equation here is velocity, or derived velocity equals 32 t to the 0. Now, what we're going to do is we're going to add 1 to this 0, and 0 plus 1 is 1, and then we're going to divide this 32t over here by 1. Well, if you divide 32 by 1, what do you get? You get 32. Alright, so velocity equals 32 t to the 1 plus c. Now, what's the c all about? Well, that's a constant. Now, I'm not going to talk about constants just yet, but I will talk about them later on. I will say, though, that you can have, from an original equation, which you derived another equation out of, the original equation can have a constant that the derived equation does not. Okay. In this case, we're going to assume that this equation has a constant. Alright. Now, if your object has not traveled at any time whatsoever, in other words, it's just started to drop and no seconds have passed, then it has not achieved any velocity whatsoever. Okay? Objects start their velocity the very second that time starts passing. Well, if no time has passed, this has no velocity. So, 0 velocity equals 32 times 0, because 0 to the first power is 1, okay? And 1 times 0 is still 0. So, 0 equals 32 times 0 plus c. Alright? And therefore, v equals 32t. Now, t represents time. T is how much time elapses from the moment that that ball drops from the top of the building. Okay? Alright, so we know now what the velocity equation is. Now, the velocity equation is an equation that has been derived from a distance equation. Alright, now you're trying to figure out how far the ball has dropped from the top of the building at any particular moment in time. This is something I explained in derivatives back in a previous set of videos. So therefore, we're going to use the Latin letter S for spatium, which was be distance, okay? Spatium equals 32t. Now this is the derived equation. We want the original equation. Alright? So, we're going to take the t here. We have t to the first power, so we're going to add 1 to that 1. Okay? Now you say, well, t to the first power. Okay, if it's got t to the first power, then it's t1. Well, that 1 plus 1 is 2. So now we have t squared. Follow along so far? Good. Now then, what you're going to do is you're going to divide this equation here by the 2, which is your new exponent. Okay? Your new exponent is 2, so we're going to divide the 32 by that new exponent, which is 2, and you'll get spatium equaling 16t squared plus c. Remember, your original equation, if you're deriving an equation from another equation, your original equation can have a constant where your derived equation may not. Alright. Now, at the beginning of this equation, we say that there has been absolutely no distance that has been traveled because no time has elapsed. No distance has been traveled, no time that's elapsed. So therefore, we have no constant. And therefore, spatium equals 16t squared. Now then, let's say we wanted to go for an interesting sports statistic. Alright, we have a baseball, we've tossed it, and we want to know how far off the ground the baseball was at any particular moment in time. We can find this out. We said in the beginning that you can have a negative velocity just as well as you can have a positive velocity. So, because we're no longer measuring the distance traveled from the top to the bottom, but rather how much height there is from the ground to the baseball, okay, because the baseball is traveling, it is falling, but it still is above the ground a certain level, we're going to now say that the velocity is negative. Okay. So we start off with velocity equaling negative 32t to the 0 to account for the fact that we're measuring the height of the ball from the ground at any one particular moment in time. Alright, so we have an anti-derived equation. Velocity equals negative 32t plus c. Remember, and I'm going to say this over and over and over again, if you have an original equation and you've derived another equation from that original equation, the original equation could have a constant which the derived equation does not. And I'll show you this as we continue on. Alright, so now we know that velocity equaling negative 32t plus c. We now know that when you started out at 0 seconds, there was no velocity, okay? Because if your ball hasn't traveled any seconds whatsoever, it has not acquired any velocity whatsoever. So therefore, we have a derived distance equation. This is your derived distance equation. Spatium, once again, equaling now negative 32t. Now, we're going to say that the equation we're looking for, which is the spatium equation, is negative 16t squared plus c. I know I didn't have the squared here marked. I'll go ahead and mark it here. Okay, we're just going to put a little like that. Okay, so spatium equaling negative 16t squared plus c. Now then, we know that the ball started out at 400 feet off the ground when we started measuring velocity and time. Okay? Now, no time has elapsed, no velocity has been achieved, but the ball was already 400 feet off the ground. So now we can put 400 in the place of spatium. So spatium, 400 equals negative 16 times 0 squared, because remember, no time has elapsed, no velocity has been achieved, but we already know the ball is 400 feet above the ground. Plus c. Well, in this case, c is going to be 400. Your constant is going to be 400. Why? Because your ball started at 400 feet off the ground. Now it's going to start falling down. Okay? So now we're going to know how high the ball is off the ground per every second that passes. Alright, so spatium equaling 400 feet minus 16t squared. So your negative 16t squared is going to end up being the distance that the ball has fallen since it got from the 400 feet. Remember, your ball starts at 400 feet and it goes down, 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 down until it finally hits the ground. So negative 16t squared will tell you how far, how many feet have disappeared since the ball has dropped from the 400 feet height. Okay, so we're going to change the S from this S in spatium, because now we're not talking about distance anymore. We're actually going to be talking about height. So we're going to change spatium to H for height. Height equaling 400 feet minus however many feet that the ball has dropped since time started to elapse. Remember, that ball is going to drop a certain amount of feet as each second passes. Alright. Hopefully you got all that. If you did not, please leave a comment below. Let me know, because there's a little more I'm going to explain in my next video. Stay tuned.